Okay, today's activity is about exploring quadratics. Anything with the x squared, they're called quadratics. So we're going to talk about graphing quadratics. So go to y equals, and this is a little different. We got x to the second power. Let's look at the graph. You're like, that looks very close to absolute value. Don't get it mixed up with absolute value. There is an actual vertex in this function as well. And you can see it's negative. It hits 0 and then it starts to become positive. And if we look at the table, we get, let's fill it out, and then so 0, 0. And the way we got that is 0 squared is the function. 1 squared is 1. 2 squared is 4. 3 squared is 9. Okay, then look at the negative one. We got 1, 2, we got 1, 4, 9. How did we get that? Well, negative 1 squared is negative 1 times negative 1. Negative 2 times negative 2 is also 4. So it's got symmetry, and like this one was 1 times 1. It's got symmetry like absolute value. It's just a little different. It doesn't have a constant slope. Okay, so I put vertex twice. Okay, you can see 0, 0. Okay, there's a cool pattern happening here. That's going down 5, down 3, down 1. So the slope's constantly changing. The change in x is 1 all the way through the interval. So the slope is kind of all over the place. And now we go plus 1, plus 3, plus 5. And again, those x's are going up by 1. So the A-rock is not consistent. It changes a lot. And most quadratics, okay, I'll tell you that part tomorrow. What I want to do is just graph it. 0, 0, that's the vertex. So I draw an axis of symmetry. All the x's are 0. Okay, let me adjust some stuff. Okay, so let's graph it. Okay, left 1, up 1. Okay, left 2, up 1, 2, 3, 4. Left 3, up 9. So you can see the slopes are completely different. Right 2, up 4. 2 squared is 4. 3 squared is 9. So it kind of makes a curvature. And see, it dropped 5, then it went right 1. It dropped 3, then it went right 1. It dropped 1 and then went right 1. It went up 1, right 1. We went up 3, right 1. So the slope's constantly changing. So it makes kind of like that U shape. Okay, it says graph both equations on the same graph with your graphing calculator. So if we want to make this go as fast as possible, okay, I'm going to do x squared plus 2. I'm going to scoot to the right. And then in y2, I'm going to do x squared. We should just look at them separately, but we're going to see what change, like what if you add or subtract something to it. Okay? I'm going to keep using the classroom one. I could do two different colors if I switch to the CE, but I'm not going to. Okay, let's look at the table. Now, maybe we should do them one at a time, because that gets kind of confusing. We got negative 11, 3, negative 2, 6, negative 1, 3, 0, 2. Then it starts going back up. So there's that symmetry again. Okay, the point it changes direction is, see, it's going down 5. The x is plus, the change in x is +1 all the way throughout the interval. Then I go down 3. Then I went down 1. Now I start going up 1, up 5, up 3, up 5. So let's go graph that. It always wants you to compare it to the parent function. So here's the parent function, just like the one above it. Okay, so there's the parent function. Okay, the vertex was 0, 0. All right, let's graph the new one. So I'm going to start at 0, 2. Okay, right 1, up 3. So basically it squared 1 and added 2. That's how I got 3. Okay, it did 2 squared plus 2. That's 4 plus 6. $311. Be like up there. Okay, left 2, up 6. And again, it did negative 2 squared, which is 4. Oh, wait. This one would go over there. My fault. And then we got one up here. Okay, so the vertex is 0, 2. So down here it says, how did x squared plus 2 change the parent function of x squared? Let me get rid of the calculator. Every time I need it, I'll just open it like a curtain. So the whole thing shifted up too. So if it was x squared plus 2, it shifted all the points up 2 from the parent. So they all just went, every point went up 2 because we did like x squared plus 2. Okay, let's see what x squared minus 5 will do. Since I taught this, I always started the vertex. So the vertex changed from 0, 0 of the parent function. Let me do this in a different color. So the vertex is 0, negative 5. So that's where I'll start. Okay, graph 1, negative 4. Right 1, down 4. So it did 1 squared minus 5, which is negative 4. 2 squared minus 5 is 4 minus 5. So that's 2, negative 1. 3, 4. So it did 9 minus 5. Okay, it has symmetry, so I can go up 1, left 1, up 3, right 1, up 5. Guess what? If we did 4 squared, it wouldn't fit. So here's the parent function at 0, 0. And when you do transformations, you compare it to the parent function's vertex, which was 0, 0. This is 0, negative 5. Basically, I took the parent function and dropped all the points down 5. So how did x squared minus 5 change it? It shifted x squared down 5. Okay, so if there is something attached to it with plus or minus, it shifts it up or down. So I've got some over here to show you. Okay, when it was positive 2, we shifted up 2. When it was minus 5, we shifted down 5. So here, this would be we shifted x squared up 6. And that's the parent function. Okay, this one, we shift x squared down 11. And sometimes I like to do this. You can just say shift up 2.5. You could move faster if you wanted to, and just use your calculator. You could move at your own pace. Okay. Now, vertex form for a quadratic. It doesn't change that much in absolute value. It's just parentheses and it's squared. So you can read it like the vertex would be -7, 0, and there's nothing out there. Okay, I want to graph the parent function. I'm doing it in pencil. 0 squared is 0. 1 squared is 1. -1 squared is 1. 2 squared is 4. -2 squared, 4. 3 squared, 9. -3 squared, 9. So they call that the parent function. And we're talking about transformations today. Okay, pause the video. I'll pause it. I'm going to have you fill out the table. So this doesn't last 20,000 years. Okay, I'm going to pause it. I'll show you how to enter it. So x plus 7 squared. Okay, see if you can fill out the table. Okay, there's the table. Graph it now. Okay, here's the parent function. Okay, so what happened to the parent function? The vertex moved over 1, 2, 3, 4, 5, 6, 7. So we went left 7. This point went left 7. 1, 2, 3, 4, 5, 6, 7. So each point went left 7. So how did that change the parent function of x squared? Is it shifted it to 7 units to the left? So it went the opposite way than you think it would. Okay, what's the vertex of this one? I've already got it in the table. All right, try putting the next one in all by yourself. Okay, make sure you use the subtraction sign there. Now see if you can make the table. There's a perfect shot of the symmetry in the table. I've got the vertex in the center. Here it is. Notice something about the y's and x's. Tomorrow we'll go more into exploring it. Okay, graph it, and then see if you can tell me how x minus 5 squared changed the parent function. Parent function's vertex is 0, 0, so it shifted the whole thing right 5. Okay, these are not supposed to bleed through the markers. Okay, let's try the next ones. Okay, and this time I'll use the actual fraction menu. All right, go to y equals, clear it, press 1, alpha, y equals, enter, 2, scoot to the right. x squared. So I hit caret 2. All right, we got 0, 0. All right, so we got 0, 0. We got 1 1/2. Got 2, 2, 3. Half of 3 squared would be a half. Up, that'd be 3.5. No, 4.5. And then there's symmetry. Okay, the way I graph the parent function so fast is 0, 0, 0 squared 0. 1 squared is 2. 1. 2 squared is 4. 3 squared is 9. And just mirror it. Okay, they call this the parent function, which is y equals x squared. Okay, we're going to talk about what happened to that function. Okay, graph these points. 1 1/2 would be there. And then 2, 2. 2, 2, negative 2, 2. So it's got symmetry. Now I go right 3, up 4 1/2, up 3, no, left 3, up 4 1/2, and if you did 4 squared 16, half of that's 8, so it'd be 4, 8. Okay, so look at the parent function. There's two things that happen. One thing vertically, okay, is it looks like we took the vertical axis and it looks like it compressed it down, is it kind of flattened out the U. So they call this a vertical shrink. And y is the vertical, that's the y-axis. Okay, what's happening to the x-axis? Okay, if I had a rubber band and I took the parent function and I stretched it out like that, it would look like that red line. So they call that a horizontal, it's the opposite. It's a horizontal stretch. And it's mainly because A is a half. Okay, try the next one all by yourself. There's another way you can do squared. So negative 2x, there's an actual x squared button. All right, keep working. I meant to do this one in blue, but now you can't see the actual numbers. This one's negative 18, negative 8, negative 2, negative 2, it's a negative 8, it's a negative 18. Okay, see if you can graph it. And okay, A was negative 2, which the parent function's the pencil, so if you flip it down, they call this an x-axis reflection. And what's it doing to the vertical or the y-axis? If I take a rubber band and I stretch it like that, it looks like we're taking that parent function and we're stretching it vertically. So it's a vertical stretch. Okay, now what happened to the x-axis? Okay, it looks like we took it and pushed the sides in, and it looks like we shrunk it. So they call that a horizontal shrink.